Check if we are live or not so that I can start the class. Okay. So we are live now. So hey everyone, hello, welcome to the session. So welcome to Unacademy ICSE and IC YouTube channel. So very good evening everyone. So tell me first, how are you all? Fine, everything going good? And also tell me in the comment section if I am clearly audible and visible to all of you. Yeah. This is Manisha, your class 9 chemistry educator. These are my credentials. I have 6 years of teaching experience. And you can join me on Telegram, on which you can get the class notes in PDF format. Also, this is a Telegram channel for Unacademy ICS and ISC boards, which you can join. The link is in the description box for every important notifications. So we have special classes ongoing on Unacademy app, where you can learn from your favorite educators. You can engage with your educator via polls. You can clear your doubts in the live special classes. So the top special classes links are in the description box, which you can join. Also, this is a special class timetable for class 9. So I have special classes for class 9 at 5:15 p.m. on Unacademy app. So you can join me over there also. And if you want to have like more serious preparations, you want to have your full class 9 or full class 10 prepared with Unacademy, you can go for your Unacademy subscription, where you can see you have so many benefits. With a single subscription, you can learn live from the home, unlimited access to all the courses, top educators, batches and courses, entire syllabus coverage. So everything you will get it in the single subscription. So we have subscriptions starting from 3 months to 36 months for class 10, for class 9 6 months to 48 months. So you can certainly go for like 12 month subscription or more than that, so that you can have your full year like tension free. You will have your classes on time, and you can attend all those classes to ace your class 10 or class 9. Okay, so whichever class you are in. And you can use my code Manisha Live to get 10% discount on all the subscribed amount. So Creative Corner is back for your ICC class 9 and 10. You can get 3 month subscription for extra if you want. If you purchase a 12-month subscription or above for Creative Corners, you can use my code Manisha Live for 10% discount. Okay. So this offer is till today, 28th of March. So do subscribe for this offer. And Creative Corner is where you can inculcate your hobbies. You can take classes related to your hobbies. This is the Creative Corner you can go with. Okay, so let's start the class now. So we'll start with a molecule. Like first we'll like to understand what is a molecule, then we will try to understand like how to calculate the molecular mass. Okay, so okay, very sorry everyone. So molecule is basically, it's a neutral group, okay, where two or more atoms are held together by a chemical bond. So if you combine two or more atoms together using a chemical bond, let's say your covalent bond, so your molecule is formed. For example, you can see your water molecule, where oxygen is combined with two hydrogen. Okay, so this is a molecule for water. If you see the molecule for nitrogen, your two atoms of nitrogen are combining together to form a molecule of nitrogen. Okay. Okay. Now ozone is also a molecule of oxygen. Calcium oxide is a molecule where you can see calcium is combining with your oxygen. So this is basically a neutral group. Why we are calling it a neutral group? Because this group does not contain any charges. They are chargeless, or you can say neutral in nature. Okay, so all molecules are neutral in nature because they have all their charges balanced. So molecule is basically the smallest unit of a substance, where it has all the properties of that substance. So if you take out a molecule of what means if you want to take out a molecule of water, and if you want to analyze its property, it will have all the properties similar to water. Okay, so this is all about your molecule. Now let's talk about your atomicity. Like, what is atomicity? Just give me a moment, everyone. Okay, so very sorry. Now, atomicity is what? What do you mean by atomicity? Okay. So, number of atoms in a molecule of an element is known as atomicity. Now, what do we understand by this statement? So, for example, you have your water molecule. Okay. So, now if I ask you how many atoms are present in this molecule of the element, that is your water or any compound, let's say, not element, compound. Okay. So if I ask you like how many atoms are present in this, you will say, ma'am, 2 atoms of hydrogen and 1 atom of oxygen. That means total 3 atoms are present in this particular molecule of your compound. Okay, that means the atomicity of water is how much? It is 3. Okay, the atomicity of water is 3 because it has total 3 atoms of 3 atoms present in it, 2 atoms of oxygen and 2 atoms of hydrogen and 1 atom of oxygen. Similarly, the chemical name and your H2SO4. Okay, this is your hydrogen sulfate or sulfuric acid, or you can call it dihydrogen sulfate. Okay, so if I ask you what is the atomicity of this particular compound or the molecule of this compound, what will you answer? So you can say like, ma'am, 2 atoms of hydrogen, 1 atom of sulfur and 4 atom of oxygen. That means total if I calculate, I am getting 7 atoms. So that means your one molecule of sulfuric acid consists of 7 atoms together of hydrogen, sulfur and oxygen. That means it has an atomicity equals to 7. Okay, this is the meaning of atomicity, like how many atoms are combining together to form a molecule of a compound. Clear? So tell me fast, if I ask you one question, tell me fast all of you. Okay. CH3COOH. If I ask you, what is the atomicity of this particular molecule? What is the atomicity of this particular molecule? What is your answer? Tell me fast, everyone. Okay, so the atomicity of this particular molecule is what? Anyone would like to answer it? Okay, so Vishal has already answered. Very good, Vishal. Yes, of course, atomicity is 8 because here you have 2 atoms for carbon, 3 plus 1, 4 atoms of oxygen, and then 4 atoms of hydrogen and 2 atoms of oxygen. If you add it all, you are getting the number as 8. That means the atomicity of your acetic acid molecule or your ethanoic acid molecule is 8. Okay. So this way you find the atomicity, that is the total number of atoms present in the molecule of any compound. Now atomic mass. What is your atomic mass? So let's discuss that first. Then we will proceed on to molecular mass, because to calculate the molecular mass you need to know the atomic masses of the atoms present in the molecular formula or chemical formula of any compound. So in an element, if you want to try out the atomic mass, how can you do that? You can calculate atomic mass by adding the mass of protons and neutrons. So as you all know that your atomic mass can be calculated by adding the number of protons and number of neutrons. Yes or no? And mass of electron we do not take into consideration because it's very small, it's negligible, almost it's negligible. So we do not consider that. Yes? Now, so all of you must know this, that atomic mass is calculated by adding the number of protons with the number of neutrons. Clear? Now, molecular mass, if you ask me what is the molecular mass, so molecular mass is basically the sum of the atomic masses of all atoms in a molecule of that substance. So if you take a substance, if you take a molecule of a substance and you see what atoms are present and how many of those atoms are present, and you calculate the atomic masses for each number of atom, and then you add all the atomic masses of all the atoms present in a molecule, then that will be your molecular mass. So how do we express the molecular mass? We express it in atomic mass unit. This is the unit used for representing the molecular mass. So let me show you an example of this, then you will understand it better. Okay, so let me show you, like, this is a molecule of water. Yes or no? In this case, you have two atoms of hydrogen and one atom of oxygen. That means you need to find out the entire atomic mass for two atoms of hydrogen and one atom of oxygen. Add them both, you will get the molecular mass of this molecule of water. Okay, so let's find out the atomic mass of two hydrogen. If you want to take out the molecular mass of this water molecule, how will we do that? Is equals to atomic mass of two hydrogen atoms plus atomic mass of one oxygen atom. Just let me write it properly for you. Atomic mass of one oxygen atom. Okay, now two hydrogen atoms ka atomic mass, how will you find out? You need to understand that what is the atomic mass of one hydrogen atom. So one hydrogen atom ka atomic mass is 1 U. So 1 into 2 plus atomic mass of one oxygen atom is 16 U. So it's 16. Add it both. So 2 plus 16, you are getting 18 U. So 18 U or 18 AMU is the atomic mass, molecular mass of this molecule of water. Clear? So how to find out the molecular mass? You just need to observe which atoms are present. First observe which atoms are present. After that, see how many numbers of each atom is present. For example, if you have some numbers written on the subscript or on the side of the atoms, that means that number representing the number of atoms present in the molecular formula or chemical formula of a particular molecule. In this case, if you see, you have two atoms of hydrogen and one atom of oxygen. That means you need to find out the total atomic mass for two atoms of hydrogen and one atom of oxygen, and then you have to add them both and you get the molecular mass. Clear? So this is how you calculate molecular mass. So for that you need to memorize the atomic masses of certain elements. At least up to atomic number 30 you should memorize the atomic masses of the element. Okay, so I have given you the atomic masses of some element. So one trick that you can use over here is that, hello, just another human, welcome to the session. So you can see over here that if any atom is having its atomic number as an odd number, you can find out its atomic mass by multiplying that atomic number with 2 and adding 1 to that. And if you have an atomic number in even form, so you just find out the atomic mass by multiplying it with the 2. Okay, so it is not true for every case, it is just a general observation that I am telling you. Okay, so for hydrogen you see it is 1, atomic mass is 1, atomic number is 1, atomic mass is also 1. Why? Because the most common form of hydrogen, that is protium, does not contain any neutrons, its atomic mass is also 1. Now helium, you can see atomic number is 2. So it's an even number. So I told you how to find out the atomic mass. You multiply your atomic number with 2 in case you have your atomic number in the even form. So 2 to the 4. It's an odd number, so multiply it with 2 and add 1 to it, the atomic number. So 3 to the 6 plus 1, 7. Clear? And as I told you that it's not true for every case, so you do not have to follow this in every case. I'm just telling you a trick to memorize the atomic mass with the help of atomic numbers of certain elements. Clear? So for example, beryllium has atomic mass 9, boron 11, carbon 12, nitrogen 14, oxygen 16, fluorine 19, neon 20. So all these are the atomic masses that we have. You need to memorize it up till at least atomic number 30. I have given here the atomic masses till 20, that is up to calcium. Okay, so these are the atomic masses of certain very common elements. Okay. So one thing I would like to tell you before proceeding further. Okay. So when you take out the molecular mass is what? Sum of atomic masses of all atoms present in one molecule. Yes or no? Now we have a formula unit mass also. Okay, what is this formula unit mass? Do not get confused. Formula unit mass is nothing but it's your molecular mass only. Okay, it's your molecular mass only. But the thing is that we use this formula unit mass, this term we use when we find out the molecular mass of ionic compounds. Molecular mass of ionic compounds. Okay. Very sorry. Okay. Clear everyone? So formula unit mass is also the molecular mass, but it's the molecular mass of ionic compounds. For example, your NaCl, your CaCl2 or CaO, all these are the ionic compounds, and if you want to find out its molecular mass, you can see that we call it your formula unit mass. Clear? So this is the difference between your molecular mass and formula unit mass. I hope it is clear to all of you. Okay, so let's find out the molecular mass of NaCl. So as I told you, NaCl is an ionic compound. So you need to understand, in this case we can call it as formula unit mass also. The molecular mass is also called as formula unit mass also. Okay, so basically we will try to find out the molecular mass of NaCl, and after this, when we complete your finding out the molecular masses of certain elements, after practicing some questions on molecular mass, we will do your empirical formula also. That is also very important. Okay, so let's try it out. So let me tell you, the atomic mass of sodium is 23 U or AMU, whatever you can say, and chlorines it is 35.5 U. So all of you who are there in the class, please try and calculate and let me know which of the following options are correct. Your 57.5 AMU, 58.5 AMU, 59.5 AMU or 60 AMU. Okay. So I will just be back in a moment. So till then, please try to answer it in the comment section. Okay, so I am back and nobody has answered. I couldn't see a single answer. Okay, so I am back and I can see Vishal has answered it. Yes, very good, Vishal. So correct, bilkul correct. Your second option is absolutely correct. Okay. So basically your molecular mass we need to find out. In NaCl, in the molecule of NaCl, you can see you have one atom of sodium and one atom of chlorine. So sodium's one atom's atomic mass is 23 and chlorine's one atom atomic mass is 35.5. If you add it both, so 538325, so 58.5 AMU is the correct answer. So option 2 is the correct one. Okay. Let's try and find out the other one. The molecular mass of glucose. Glucose formula I am writing C6H12O6. This is the formula for glucose. You all need to identify which is the correct molecular mass of glucose. Is it 180.096 AMU 190.096 AMU, 181.096 AMU, or 130.096 AMU. So all of you please try and answer this thing. Yes, all of you try and calculate. Let me tell you the atomic masses of carbon. So carbon's atomic mass is 12 AMU. Hydrogen's atomic mass, all of you must be knowing, so 1 AMU. And oxygen's atomic mass is 16 AMU. So this is the atomic masses of individual atoms present in this molecular formula of your glucose. So let's try and find out. As I told you, you need to add the entire atomic masses together to find out the molecular mass. You can see we have here 6 atoms of carbon. That means if the atomic mass of one atom of carbon is 12 AMU, what will be the entire atomic masses of your 6 atoms of carbon? So for that, 6 into 12 plus 12 hydrogen atoms we have, so 12 into 1 plus 6 atoms of oxygen we have, so 6 into 16. So let's try and find out. So 12 6 just 72 plus 12 plus 16 6 96. So the answer we are getting over here 6 to 8 to 10, 9 7 16 1 17 80. So 180 AMU is the correct answer. So option 1 is the correct one. Okay, so this way you can find out the molecular mass of any compound. Let's try some more question. So a substance which has a formula mass of 133.5 AMU is. So which of the given substances, which of the given molecules of the compound has the formula mass of 133.5? Let me tell you the atomic mass of magnesium, it's 24 AMU. Sulfur, it's 32 AMU. Boron, it's 11 AMU. And aluminium, it's 27 AMU. Chlorine, it's 35.5 AMU. So all of you please try and solve this one. So which one is the correct answer? So let me solve it fast. So we will start from the fourth one, okay? Because it's a very high atomic mass. It's a very high molecular mass. So we will start with the last option. So aluminium chloride. So you can see you have one atom of aluminium. So 27 plus 3 atoms of chlorine. So 3 into 35.5. Let's add it. 27 plus 3 5 15. 3 5 15 1 16 3 3 9 1 10. So add it 6 7 6 13 2 or 3. Here 5 7 6 13. So 133.5 AMU. Got the answer? So option number 4 is the correct one, which has the formula mass unit of 133.5 AMU. Clear? So in this way you can solve all the questions related to your molecular mass. Any doubt till here, anyone? And if you are really liking the classes, please do not forget to like it and share it with your friends so that maximum students can join us on this platform. Okay, chalo. Let's have some more questions. See, I am making you practice these many questions so that you can understand how to find out the molecular mass and you do not do a mistake when it comes to solving questions. Okay. So molecular mass of C3H8, that is your propane. So what is it? 106 AMU, 44 AMU, 98 AMU, 102 AMU. So let's find out what's the answer here. Okay, so one student has already answered. Okay, Vishal has answered as A. So let's see what is the correct answer over here. Okay, so you have 3 atoms of carbon and 8 atoms of hydrogen. So 3 into 12 plus 1 into 8. 12 3 is 36 plus 8. So you get 44 AMU. So correct answer is option number B and not option number A. So 44 AMU is the correct one. Okay. The next one, the molecular mass of Na2CO3 is. So what's the molecular mass of Na2CO3? Let's find out. So 2 atoms of sodium. So 2 into 23 plus 1 atom of carbon. So 12 plus 3 atoms of oxygen. So 3 into 16. So 2 3 is 6, 2 2 is 4 plus 12, 16 3 is 48. Let's add it. 6 2 8 8 16, 4 4 8 8 9 and 1 10. So 106 AMU is the molecular mass of sodium carbonate. Clear? Next is, what is the formula mass unit of zinc oxide? So zinc atomic mass is 65 AMU. So zinc oxide you have, that means one atom of zinc and one atom of oxygen. So 65 plus 16, what you get? So 6, 5, 11, 6, 1, 7, 8. 81 U, that is your, the correct answer is option number B. Then we have to calculate the molecular masses of the following. Let's do it fast, and after that we will move on to your empirical formula of a compound. Okay. We have to calculate the molecular masses of C2H5OH. So if you want to try it, if you have understood like how to calculate this, so please try it on your own, and I am also solving it. So 2 carbons, so 2 into 12, 5 hydrogens, so 1 into 5, 1 oxygen, so 16, then 1 more hydrogen you have, so that means you have total 6 hydrogens. Add it, 12 to 24 plus 6 plus 16, answer you're getting 24 plus 6, 30 plus 16, 46 AMU is the molecular mass of this ethanol. Clear? Then PbI2. So we need to find out the molecular mass of PbI2, that is lead iodide. So tell me fast, what is the atomic mass of, what is the atomic mass of your iodine? Anyone? Okay. So lead I have already given you. Lead's atomic mass is 207 U and iodine's atomic mass is 127. It's basically 126.9. Okay, 126.9. So you can write it as 127 AMU also. Clear everyone? So this is the atomic mass of your iodine. Now let's try to find out the molecular okay, so just give me a moment. So I'm having a little cold today, so that's why this problem is happening. Okay. Now in this case you can see one atom of lead you have, so that is 207 plus 127, so 7 and 14, 213, 213, 334 AMU is the correct. Sorry, we have here 2 atoms of iodine, no, because PbI2 it's written. So we have 2 atoms of iodine, so that means this is not the correct answer. We need to multiply 127 with 2. We get 207 plus 2 7 are 14, 2 2 are 415, 202. 7 4 11, 5 8 6, 2 2 4. 461 AMU is the correct answer. Clear? Next we do not, okay. Next we have your HNO3. Let's find out. H is 1, nitrogen is 14, AMU is the atomic mass for nitrogen. 16 3 are 48. So 14 plus 1 15 plus 48, how much you're getting? 63. So 63 AMU is the atomic mass at molecular mass of your nitric acid. Then we have barium sulfate. Barium's atomic mass is 137, sulfur's atomic mass is 32 and oxygen's atomic mass is 16, but here we have your 4 atoms of oxygen. So total atomic mass will be 16 into 4. Let's add it. So 137 plus 32, 16 4 is 64. You get 7 2 9 4 13. 3 6 6 12 1 13 1 and 2. 233 AMU is the correct molecular mass of barium sulfate. Magnesium hydroxide. So how do we find the molecular mass of these types of compound? So here you can see ki your 2 is written on the outside the bracket, that is encircling your OH. Okay. So here you can see, that means we have 2 atoms of oxygen and 2 atoms of hydrogen. So whenever you have such a subscript written over here where you outside the bracket you have the number, so that number stands for all the atoms present inside the bracket. So in this case you have 1 atom of magnesium, so at magnesium's atomic mass is 24, 2 atoms of oxygen, so 2 into 16 plus 2 atoms of hydrogen, so 2 into 1, add it, 24 plus 16 to the 32 plus 2, so 4 to 6 to 8, 3 to 5, 58 AMU is the atomic mass, molecular mass of magnesium hydroxide. Then sodium hydroxide, so it's 23 plus 16 plus 1, so 6, 3, 9, 1, 10, 23, 40, 40 AMU. And CaSO4.2H2O, how do you find out the molecular mass of this particular compound? So calcium it's 40, sulfur is 32 plus oxygen. How many atoms you have here? You have here 4 atoms of oxygen here and 2 atoms of oxygen here. So whenever you have a compound written like this, that means you have 4 atoms of hydrogen and 2 atoms of oxygen. So this number also stands for all the atoms present after the number. Okay, so that means you have 2 atoms of oxygen, that is 16 to the 32. So let's write that, plus 2 to the 4 atoms of hydrogen, so 1. You get how much? 40 plus 32 plus 32 plus 4. So 32, 32, 64. 64 plus 44. How much you are getting? 108 AMU. Or you could have find out like this also. For example, you have like calcium sulfate dot 2H2O. So here let's find out the molecular mass of this. So Ca is 40, sulfur is 32, oxygen 16, 4 just 64. Okay, very sorry, I have created some mistake. Okay. So here I have done a mistake over here, because here I have taken the number of oxygen to be 2 only, but that has to be 2 plus 4, 6, no, because here you can see, so it's not 108 AMU. Very sorry for the calculation error. In this case 4 plus 2, 6 oxygen you have, no, 16, 16, 96 you will have. Yes. So 40 plus 2, 2, 4, 3, 7, 72, 16, 16, 96 plus 4, you get 96 plus 4, 100 and 172 AMU is the correct answer. Okay. So here you can see 16 plus 64 plus. This is your water molecule. Yes, and you have 2 molecules of water attached to your calcium sulfate. That means if you know the molecular mass of water molecule, if you multiply it by 2, you get to know the molecular mass of this entire unit. So molecular mass of one water molecule is 18 AMU. So the 2 water molecules will have the molecular masses 2 into 18, add it all. So 2, 4, 3, 7 plus 64, 18 to the 36. Add it all, 6, 4, 10 to 12, 1 carry, 6, 3, 9, 7, 16, 170. So 172 AMU. So right like this also you can do it. So this is the way how do you find out the molecular masses of different molecules of the compounds. Clear everyone? Any doubt anyone is having? So if anyone is having any doubt, please let me know. Okay. Now we will go on to find out the empirical formula of a compound. Okay, empirical formula of a compound. How do we do this? Now first of all, what's the empirical formula? You have to understand that. Okay, empirical formula क्या होता है? That you need to understand. After that we will go on finding it, how to find out it. Okay, just give me a moment everyone. Okay. So first of all, empirical formula of any compound is the simplest formula. It's the simplest formula of a compound. Okay, simplest formula of a compound which gives the simplest whole number ratio of different atoms present in one molecule of the compound. Which gives the simplest ratio in whole numbers. Okay, simplest ratio in whole numbers of atoms present in one molecule of compound. This is the empirical formula of a compound. Okay, simplest formula of a compound which is giving the simplest ratio in whole numbers of atoms present in one molecule of the compound. Let me show you an example. What do we mean by this? That simplest formula and all. For example, you have hydrogen peroxide. This is the molecule of your hydrogen peroxide. Now in this case, you can see you have two atoms of hydrogen combining with the two atoms of oxygen to form this hydrogen peroxide. Now what will be the simplest ratio of this? If you see, the simplest ratio of your hydrogen is to oxygen will be how much? So it has to be like, if you write 2:2, it will come out to be your 1:1. That means this is the simplest ratio of hydrogen and oxygen present in the molecule of your hydrogen peroxide. That means if you write the simplest formula, if you want to write the simplest formula of hydrogen peroxide, what will it be? Simplest formula of hydrogen peroxide is, of course, HO, because 1:1 is the simplest ratio. So of course the hydrogen peroxide simplest formula will be your HO. Yes, one atom of hydrogen and one atom of oxygen. So in this way you can see empirical formula represents the simplest formula of a compound, and in which we write the simplest ratio, and that too in the whole numbers of every atom of every element present in one molecule of the compound. Clear? Now in this case you can see we are dividing the numbers of atoms present in actual formula by a common factor. Yes or no? In this case also your actual numbers of hydrogen and present in hydrogen peroxide is 2 and 2. We divide both the number by 2 only because that is the highest common factor of both the numbers representing the number of atoms present in the molecule of hydrogen peroxide. Okay? So that means we have to find out, okay, what we need to find out the empirical formula, we need to follow some steps. Okay, so to find the empirical formula, we need to follow some steps. What are those steps that we are following here to find out the empirical formula of some compounds? Okay. First is that find HCF of the number of atoms present in the molecular formula of any molecule of a compound. So first of all you need to analyze like how many atoms of each element is present in one molecule of a compound, and then you have to find out the HCF of all those numbers of atoms present in the molecular formula of any molecule of a compound. After you have found out the HCF, so let me show you how to find out the HCF. For example, you have a molecule of glucose. This is a molecule of a glucose, yes or no? Yeah, this is a molecule of a glucose. Now in this case you can see you have 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen. So these are the different numbers of carbon, hydrogen and oxygen present in one molecule of the glucose. You need to find out the HCF of all these 3 numbers. So HCF of 6, 12 and 6 will be 6 only. Okay. So this way you find out the HCF of the number of atoms present in the molecular formula of any molecule of a compound. आफ्टर वी हैव फाउंड आउट द HCF, हमने HCF निकाल लिया, डिवाइड द molecular formula of a compound with the HCF calculated. So the HCF that you have calculated, you have to take that HCF and you have to divide the entire molecular formula of a compound with that HCF. For example, if you have C6H12O6 and you divide it by 6, or you can write it like this also. If the ratio of C, H and O is present in the form 6 is to 12 is to 6, you divide it by 6. What is the answer you are getting? 1 is to 2 is to 1. That means if you write these numbers as a subscript beneath your carbon, hydrogen and oxygen, that means that will become the empirical formula for your glucose compound. Okay, or glucose molecule. So if I write it here, empirical formula of a glucose molecule okay, so empirical formula of a glucose molecule, what will it be? Your CH2O. CH2O, this is the simplest formula of a compound and it is the representing the simplest ratio in whole numbers of the atoms of different elements present in the molecule of the compound. Clear everyone? So in this case you can see this is the empirical formula of the glucose molecule CH2O. Now you need to understand here one more thing, okay, that is represent HCF as N. Okay, you have to represent your HCF as N. Just give me a moment everyone. Clear? So you have to represent the HCF as N, and how do we find out the empirical formula? Empirical formula of any molecule is equals to molecular formula divided by that N. Okay, so this is how you find out the empirical formula. Okay, so let's find out the empirical formula of some molecules of the compounds. Let's find it out for your let's say which one we want to find out. Okay, so so let's do it for okay, just let me give you some questions here. Okay, so let's find out the empirical formula for benzene. Benzene's molecular formula is it's your C6H6. Okay, this is the molecular formula for benzene. Clear? So let's find out the molecular formula for empirical formula for benzene, all of you. Let's do it. Try and solve it everyone. Okay, so I'm just going to do it. As I told you, empirical formula of any molecule is equals to molecular formula by N. Yes or no? So you need to see, and N is what? It is the HCF. You need to see here that you have 6 atoms of carbon and 6 atoms of hydrogen. That means your N is 6 over here. That is the HCF is 6. Empirical formula, if you have to find out, that is equals to molecular formula by N. So molecular formula is C6H6 divided by 6, so it will become CH. So this is the empirical formula for your benzene. Clear? So empirical formula for benzene is this. So this is the way how do you find out the empirical formula for any molecule of a compound. Clear? So let's now solve some questions so that you will have a better idea to how to find out the empirical formula as well as your empirical formula mass also. Okay, so I will teach you first like how to find out the empirical formula mass of any molecule of a compound, and after that we will find out the empirical formula as well as empirical formula mass also. Okay, so let's do that first. So how do you find out the empirical formula mass of any molecule of a compound? So empirical formula mass. So to find out the empirical formula mass, you just need to write down the first empirical formula and then you have to find out the mass. For example, empirical formula of glucose, so all of you know this only. C6H12O6 is CH2O. Now if you find out the empirical formula mass of glucose, okay, formula mass of glucose, so you just need to do one thing. You have to find out the sum of the atomic masses of all the atoms present in the empirical formula of glucose. Okay, so sum of the atomic masses, what you need to do, you need to find out the sum of the atomic masses of various atoms present in the empirical formula. So empirical formula is CH2, that means 1 carbon, so 12 plus 2 hydrogens, so 2 into 1 plus oxygen is 1, so 16 added, 12 plus Yes, am I visible and audible to everyone in the class? Audible to everyone in the class? Yes, it's back now. Okay, very sorry for that. All the problems that you have faced right now. So let's be back with the class. Okay. Okay. So empirical formula empirical formula mass I was teaching you how to calculate. So basically you can do it by adding the atomic masses of various atoms present in the, just give me a moment everyone, various atoms present in the empirical formula of a compound. Clear? So for example, empirical formula of your glucose was CH2O. So what will be the empirical formula mass of this particular empirical formula? So just calculate that. So 12 plus 2 plus 16. So it's coming out to be 30 AMU. Okay, this is the empirical formula mass. This is the way how you find out. Or you can do one more thing. Okay, you can do one more thing. That is your empirical formula mass can also be calculated by dividing the molecular mass by the N, the HCF that you have find out. Okay, so let me show you an example. So let's find out the molecular mass of glucose. C6H12O6. What is the molecular mass of glucose? 12 into 6 plus 12 into 1. Sorry, 6 into 12. 12 is 72. 12 into 1 plus 16 into 6. So 12 is 72 plus 12 plus 96. 6 to 8 to 10, 9, 7, 16, and 17, 80. 180 AMU is the molecular mass of your glucose. Okay? What is the N over here? 6, because if you find out the HCF of number of atoms of carbon, hydrogen and oxygen in the formula of glucose, you will get HCF as 6. So that means here N is equals to 6. So if you have to find out the empirical formula mass, you can simply divide your molecular mass by 6. So 180 by 6, you get 30 AMU. Clear? So the similar answer you are getting here also, you can see. Okay. So similar answer you are getting here also. 30 AMU. Yes or no? Okay, so similar answer you are getting over here also. So anyway, you can find out the empirical formula mass of different molecules. Okay, let's find out one more and then we will proceed back. Okay, so just find out one more. You have to find out the empirical formula and mass of, let's say, butane. Okay, so butane's molecular formula is C4H10. This is the molecular formula. If you find out the first of all, तो हमको क्या find out करना है यहाँ पर? Let's find out your N. So N is the HCF of 4 and 10. So 4 और 10 का HCF क्या हो जाएगा? You will get it as 2. Now divide to find out the empirical formula of this butane. You have to divide the molecular formula by N. So C4H10 divided by 2. So you get C2H5. This is the empirical formula for butane. Now empirical formula mass, if you remember the molecular mass, okay. So tell me fast, am I clearly visible and audible to all of you? Okay. Okay, just give me a moment. Yeah. So empirical formula mass, if you want to find out, you simply find out the empirical formula mass of C2H5. So 2 atoms of carbon, so 2 into 12 plus 5 atoms of oxygen, so 1 into 5. So 12 to the 24 plus 5, so you get 29 AMU. Or if you remember the molecular mass, you can divide that molecular mass also by HCF. Same answer you will get here. Clear? Just give me a moment, everyone. I think some technical problem is happening. I don't know why. Okay. Please, all of you tell me who are there in the class. Can all of you means see me clearly, hear me properly? Yes or no? Okay. Okay. So that was all for today. Calculation of molecular mass and empirical formula mass as well as empirical formula. So I hope you liked the session, and if you are interested in joining the plus courses, let me tell you about the plus courses. Like, we have your champions batch for class 9 already started from 2nd of March, and in the month of April also we will have certain courses starting for the new academic session for your class 9 students and as well as for your class 10 students. Also, your midterm portion will be followed in those courses, and your entire coverage of the syllabus will be done. So you can see your India's top educators are taking the classes in these courses. So you can join these courses by taking the plus subscription. Also, for students moving from 9 to 10, for them also we are starting the new academic sessions from April. So you can go for the plus subscriptions. So we have a new feature called community on your Unacademy app. So on communities, you will get the updates from your favorite educator. You can follow them and you can get the updates from your favorite educator on communities. You can get sessions, notes, practice material on the community, and you can also share your feedback directly with educators via polls. And my educators community link is given below in the description box. You can join that community by clicking on the link. Okay, so on this community you will get all my specialized session notes, practice material, questions, polls. Also you can talk to me on this educator community section. Okay, so please, and you should all means try at least once and see what are the benefits you have, and I am sure you will like it. So for this you need to download the Unacademy app. So this is very simple. Just download the app, follow the instructions, and you can watch my special classes, join the community, follow me on Unacademy, and using my code Manisha Live will help you to unlock all the free special classes. Okay, so do join these all free special classes with the code Manisha Live. Also, Unacademy has launched your Bugs Bounty feature. This is the opportunity for all learners to report any inappropriate content if you found in any video, and if your reporting is found to be true, so you will get the prize. Okay, so the form is in the description box. You can fill that form over there. So thank you everyone. Thank you for watching the session live. Please do share these sessions with your friends, and do not forget to subscribe to this channel, because without subscribing you won't get the notifications of the classes whenever we go live. Okay, so thank you, bye. Let's meet again tomorrow at the same time on same channel, that is at 4 p.m. So bye everyone, thank you and have a nice day.